site at our location in Jenny Jump State Park in Hope, New Jersey. Um, However, tonight, since it is absolutely horrible as far as weather outside, there has been a quick change up. As you can see, we are actually indoors right now, and we do have a couple of public, and actually they are getting set up to view this outdoors, much like a drive-in movie theater. So they'll be able to see and hear through their cars. Um, they can also, if they're having trouble with seeing the presentation or hearing audio, they're also being directed to our YouTube stream. We are actually live streaming this through our YouTube. You can check out tonight's presentation that's live after we're over. You can also go back and see all our past presentations that we've done this way since the beginning of the whole COVID pandemic. So, like I said, weather has been less than ideal, so it's a slightly different setup tonight. Uh, while I'm just waiting for our people outside to get everyone settled, I just want to go over a couple things. Uh, do check out our website, uacnj.org. It stands for United Astronomy Clubs of New Jersey. That is where you will find all of our info on our clubs, our member clubs, because this is actually a club made up of all the other clubs. You'll find out information on them. You can find out information on what programs we have coming up as scheduled. You can also find out information on the various telescopes and observatories we have on the property. Uh, in addition to our website, you can check us out on Facebook, Instagram, Twitter, our new Discord channel that we're trying to get going. Because all that feedback does actually help us figure out what you guys want to see. We are a nonprofit. Everyone you have seen, whether you've come here, everyone behind the scenes, is all doing this as a volunteer and has all been able to happen because people have actually donated money through us, even throughout this pandemic, kept this going, has allowed us to keep offering these free public programs. So, like I said, there have been a couple changes. Normally, this is when I'd go over the safety briefing for those people here. So, a couple things. Like I said, I know we do actually have a couple people set up outside in their cars viewing this like a movie theater. For those of you doing that, we do actually have a public restroom. It is the porta potty that's outside that I'm pointing to that you guys on camera can't see. And neither can you who's viewing it now that I think of it. But it is illuminated by a red light, so you'll be able to do that. When you're leaving, please use your headlights because getting run over is not fun. Also, if you happen to be here and again you're in your car, after the presentation, do check out the little gift shop. It's inside the main building house with the door with the red light outline. For those who might be a Girl Scout, Boy Scout, I think we have a scouting group coming up. You'll be able to get your some UACNJ patches and other fun things. So with that, our presentation tonight is At Home in a Dome, Building, Automating, and Using a 6-Foot Dome Observatory with Bill Murray. Bill has been an amateur astronomer for more than 50 years. He was employed as a software engineer in the Electron Optics Division of the David Sarnoff Research Center in Princeton for 18 years. More recently, he has taught high school mathematics and physics at Trenton Catholic Academy in Hamilton, New Jersey, and is currently employed as a planetarium technician at the New Jersey State Museum Planetarium in Trenton, New Jersey. A long time ago, 36 years, that's still correct? Member of the AAAP, Bill has held the posts of Observatory Chairman, Secretary, Program Chairman, Assistant Director, and Director of that club. And with that, Here's Bill.
Thank you, Kim. Pleasure to be here tonight, although the weather could be better. I'd like to take some time tonight and describe an ongoing 15-year project that I've been involved in planning, building, using, and now automating an observatory in my backyard. So let's start off at the beginning, always a good place to start, and talk a little bit about why build a backyard observatory. So I've been an amateur astronomer, as Kip said, for 50 years. And if you've ever done amateur astronomy, you'll know that setting up a telescope can be a major effort, especially, and it gets worse the bigger your telescope is. So you usually spend some time, from anywhere from a few tens of minutes to an hour or more, setting up your telescope in your backyard or wherever you plan to do observing. And then typically what happens is the clouds will come in and you have to spend an equal amount of time to break it down. So one reason to build an observatory in your backyard is that it's a convenient setup. You can set up your equipment once and for all, and you never have to take it down again or set it up again. It's always ready for you to use as soon as you open your observatory. Another reason to build a backyard observatory is it allows you to get highly accurate polar alignment. We happen to live on a moving platform. The Earth is turning around once every 24 hours. That's fine for us here on the Earth. It gives us day and night. But it makes it very difficult to look at objects in the sky, because if you point, for instance, at the moon, the telescope that you're looking at the moon with will magnify the image of the moon, but it will also magnify the Earth's motion. So within just a few seconds, the moon will move out of your field of view. If you want to counteract that motion, you need to have a mount that turns to counteract the rotation of the Earth. And that, in order for that to be done accurately, you need to have your mount pointed very accurately at the North Pole, near the North Star. And if you're setting up a telescope, that's a procedure that can take anywhere from a few minutes to almost an hour, depending on how accurate you want it to be. If you have a backyard observatory, you do it once and you never have to do it again. Another reason for a backyard observatory is protection from wind and lights. Telescopes out in the open are subject to the vagaries of local lighting. There always seems to be one very bad light that's shining in your eyes as you're trying to observe the night sky, and also subject to wind. If even there's a light breeze blowing, it will blow your telescope and will disturb your image that you're trying to view. If you have that telescope in an observatory, you can be largely protected from both of those effects. Another reason for a backyard observatory is security. You can leave your equipment set up permanently and know that when you're done with it, you can lock it up in a secure place where it will be safe, and you never have to take it down. And also, there's less wear and tear on the equipment. Continually putting up and breaking down a telescope makes there a lot of wear and tear on the equipment. There's always the possibility you might drop something and break it while you're setting it up or taking it down, something that has happened to me numerous times. Once you have the equipment set up in your observatory, you'll never have to worry about that again. And the only wear and tear on the equipment is its actual use when you're viewing the night sky. And also maintaining the orientation of your imaging setup. If you have a camera attached to your telescope, it's always a good idea, once you set up that camera on your telescope and focus it, not to move it again. Something that's impossible to do if you have to take your telescope down every night. So having an observatory allows you to maintain the orientation of that imaging setup. So now that we have some reasons for why you would want to build a backyard observatory, where do you want to build a backyard observatory? If you're building it in your backyard, the things that you want to consider are the following. So most of us do not have access to an observing site that has horizon to horizon views. Most of us are trying to observe with some obstruction from trees and buildings and other obstacles. But if you can choose the location for where you would put your observatory in your backyard, the main thing that you want to consider is that you have access from the north to the south along the meridian, which is the line that runs from north to south through the zenith, the point exactly overhead. At some point in time, all celestial objects will rotate through that line, and so you'll be able to see them during the year. You may not be able to see them all the time, but there will be some certain time during the year when they will rise high enough to be visible from your observatory. The next consideration is having a clear eastern horizon so that you can see objects as they're rising in the east in the evening skies. A clear western horizon is nice as well, so you can see objects before they set. The least important is the northern horizon, because as I said, objects that are low in the north, eventually at some point in time, 6 months later, will rotate until they're high in the north and be visible. My observatory is actually fairly well obstructed to the north, but it really doesn't make a difference in terms of what I'm observing. So now that we know, also local lights, sorry, you want to put an observatory in a location in your yard that has very little local lights, if you can do it, or block your neighbor's lights. So one thing that I've done for my observatory is I planted a row of arborvitaes along the northern fence line, just behind where my observatory is. When I show you some pictures, you'll be able to see them. And they block all the light from my local neighborhood coming through. And lastly, wind conditions. If you can put an observatory in a location in your yard that is less subject to wind, that's an advantage as well. And the last consideration is property boundaries. So there are some zoning restrictions that require you to build structures a certain distance away from the boundary of your property. So that's a consideration in where you want to put your observatory as well. So now that we know where we're putting our observatory, let's talk a little bit about what that observatory would look like. Generally, there are two main observatory types. If you come here to Jenny Jump, you'll be able to see multiple examples of one of those types, and that's the roll-off roof observatory, shown here in the picture to the left. This is a very small roll-off roof observatory that was first brought to the attention of people in the June edition of Sky and Telescope magazine, Dennis DeCicco's so-called doghouse. A roll-off roof observatory is a building that houses a telescope, but the roof is able to be removed in some way. In this design, the roof actually rolls off on rails that are behind the observatory to allow the telescope to see the night sky. When you are done view with the telescope, you can roll the roof back to protect it from the elements. The other major type of design for observatories is a domed observatory, shown here. This is a Technical Innovations home dome. Not to give stuff away, but that's actually the type of observatory that I have, and I'll go into in a few minutes why I chose that. So let's take a look at some of the advantages and disadvantages of both of these types of designs. So roll-off roof observatories have the advantage that generally they're lower cost. You're buying the materials yourself, and you can do some cost analysis to get the cheapest elements for building that you want. You generally can make them a better fit with existing structures, go with a paint scheme on your house, make them look very similar to a garden shed so that people won't really know what they're for. And the other advantage for roll-off roof observatories is that once the roof is removed, you have full access to the sky. Anything that's visible from the skies in your backyard, you will be able to see from your observatory. Disadvantages are generally they require a higher amount of planning and construction work on your part if you're building them. Some materials may be a little bit difficult to find, so you may have to go through a search to find the materials that you want. And they also tend to give less protection from wind and light. That's a counterpoint to the full sky access. You can see the full sky, but if there are any lights in your neighborhood or if the wind is blowing that night, your telescope will be subject to those as well. Dome observatories have the advantage that you have better protection from wind and lights, and all materials are included. Generally, domes tend to come as kits, where you have all of materials included in the kit, so you don't have to buy extra materials, except for a platform to put the observatory on. But some of the disadvantages of a dome are higher cost. The kits tend to be more expensive than building your own roll-off roof observatory, and you get a limited sky view. Unlike roll-off roof observatories, you're limited to a section of the sky, but that's, again, a counterpoint to the fact that you're protected from wind and light. So after considering all of these things about 15 years ago, I decided that if and when I built an observatory in my backyard, that observatory was going to be a dome. And of the various companies that do make domes, there are several. I decided to go with Technical Innovations and their Home Dome 6, a 6-foot diameter private observatory. And the main reason I chose that was I needed protection from wind and lights in my backyard. That was my most important consideration. So about 15 years ago, my wife and I decided to do a major rework of our backyard. At that time, we had removed a deck that was on the back of our house, put in a completely new deck, as well as a stone patio. And while we were talking to the architect to design that, I said, oh, by the way, I would like to have an observatory as well. And so we decided to add that to the plan. I'm going to briefly interrupt my PowerPoint presentation here to show you some of the plans that we came up with for that. So this is the architectural drawing for the decking for the observatory. So it's basically a 10 by 10 foot area footprint of composite material, and it's supported on 4 independent concrete piers that go about 32 inches into the ground. They support the observatory base, but then there's also a central pier for the telescope that is actually isolated from the whole structure, so that it is stable, and walking around on the floor does not make any vibrations which might affect the telescope view. Okay. Also, I wanted to make sure that I had electrical power in my observatory. So I had a power line run from my house, as is shown in this diagram here. It runs through the platform base to where the pier is, to a PVC pipe that was embedded in the concrete, and brings the electrical connections up to the base of the pier. And going back to my PowerPoint presentation again. Let's see, there we go. So you can see here so I'll go back one. So this is the area of my backyard where I plan to build the observatory. These are you're looking towards the north right now. These are the arborvitae trees that I planted to eventually grow up and block the view of my neighborhood and any lights from the neighborhood. And you can see here the post holes have been dug for the 4 piers that are going to support the observatory fitting. And we're just about to dig the post hole that's going to be the position of the observatory pier. A few weeks after this, this is the deck and patio, and here's my observatory base, which is a little bit off of my patio. You'll see here, if you look closely, there are 3 threaded steel rods that are sticking up out of the telescope pier. When the concrete for the telescope pier was being poured, I actually used a template to place those rods in the concrete, and those will be used to attach the telescope pier itself to the concrete base. So here's a general schematic of what Technical Innovations Observatories look like. There's a base wall that has a semi-door in it, and the dome is made up of several quadrants that are bolted together and a shutter that can be retracted back and forth over the top of the observatory. It can be actually retracted far enough that you can see directly overhead. And the dome rests on wheels which are attached to the dome support ring, which is at the top of the wall. So the dome is free to rotate with just a slight push as you move it around. I had originally planned to completely document the building process for my observatory after the kit arrived. I was sure that it was going to be a multi-weekend effort to put it together, so I thought I would have plenty of time to actually document the procedures of building it with images. I was mistaken. The total time to actually construct the observatory was a day and a half. And most of that time was taken up on the first day bolting together prefabricated sections. The actual assembly of the observatory took less than 6 hours, and the hardest part of that was making sure that the base ring, the base wall, was actually level. I had to take a fair amount of time to actually make sure that it was completely level. If it wasn't, then the dome would not be able to turn freely. So here's a view of me entering my observatory. I usually keep it locked, even though it's in my backyard, just to secure the telescope in it. After unlocking the observatory, I can slide back the shutter, excuse me, and then open the door of the observatory so that I can enter it. The original telescope that I had there was this telescope, a 10-inch Meade LX200 Schmidt-Cassegrainian telescope, which is now in the possession of UACNJ for their use, because I donated it to them. For many years, this was my telescope. I got a lot of enjoyment out of it. Here's me sitting in the observatory. You can see here there's a small tray with my eyepiece case. This is the base of the pier, so you can see the threaded rods that were embedded in the concrete are now holding up the metal pier. This is the other side of the pier. The electrical connections that ran up through the concrete went into the pier and to this power outlet here on the pier. This is the sole power that's available in the observatory. So one thing that I do as a safety precaution is that whenever I leave the observatory and I'm done for the night, I make sure that everything that is plugged into those outlets is unplugged. And that way I know that everything has been powered down. And also, previous image, I didn't say this, but you can see in my observatory there's a bump out on one of the walls. That was a design option that I chose. You can have up to 3 bump outs on your observatory. I chose to have 1 to give me a little extra space inside. And initially I used that bump out to park a TV stand that I had sitting in my basement and hadn't been used for a while. And I repurposed that to be a container for tools and eyepieces, observing almanacs and books and star maps, and has a few lights on it as well. And so for the first pass, that was my observatory. I got many years of use out of it, a lot of enjoyment, made astronomy setup much easier for the telescope that I had, which you can see was fairly large. It used to take more than an hour to set it up and a similar amount of time to break it down. Once I had my observatory, I could open up my observatory in less than 5 minutes and have the telescope operational, and take also about 5 minutes to close it down at the end of the night. Made telescope setup much easier to do. But as is common, once you have a setup like this, you begin to think about what more can you do with it? And so I began to think about doing astroimaging from my observatory, which is possible if you have a permanently set up telescope. At least it's a lot easier if you have a permanently set up telescope. There are two basic types of astroimaging. One is long exposure deep sky astroimaging. There are several people here at UACNJ who are expert at that type of imaging. If you come here on a clear night, you may see them with their telescopes set up here. But I decided to go a different route. I became interested in video astronomy. So I want to take a few minutes and talk a little bit about video astronomy because that's basically what I use my observatory for these days. So what is video astronomy? So it's also known as electronically assisted astronomy, EAA, and it's the capture and display of astronomical images with a video camera in near real time with minimal, if any, post-processing. And by near real time, I mean anywhere from a few seconds to a few minutes. So if you had to design an ideal video imaging system, what would that camera do? What properties would it have? Well, you want to have high resolution in your camera so that you can see details in astronomical images. You want that camera to be very sensitive to low light levels so that it picks up very faint details. You want a camera that has unlimited exposure so you can take exposures on your image frames as long as possible. You would also like that camera to be cooled. We'll talk about that in just a minute. You want to have the ability to stack images to achieve greater resolution and greater detail in your image. You like the ability to save those images once they're taken. If possible, you can have a color camera rather than a black and white camera, and a large sensor size for a larger field of view and a larger image, and relatively cheap if possible. And I can pretty much guarantee that if the camera meets the first 8 requirements, it's not going to meet the last one. Cameras that meet those 8 requirements do exist, but they're not cheap, relatively expensive. So let's take a look at some of these qualities and talk a little bit about why you would want to have them in an imaging system. So you want a cooled camera. Modern video cameras and CCD cameras are sensitive to heat. They detect heat in the same way they detect light. And so if your camera is not cooled and it's warm out, which is sometimes true during the summer when a lot of people do astroimaging, your camera will pick up that ambient heat as light and it will pollute your image. So shown here are 2 images, one from a cooled camera, one from a non-cooled camera. The non-cooled camera is on the left. The subject being photographed is the Seagull Nebula. And you can see in the left images there's a lot of noise in that image. And most of that noise comes from thermal pollution of the image because the camera wasn't cooled. If you use thermoelectric coolers built into your camera to take the camera and cool it down to about 20 or 30 degrees negative Celsius, you can get rid of most of that noise and the image will look more like the image on the right. So if you're going to take long exposures where thermal noise is a problem, you would really like to have a cooled camera to alleviate that problem. Another thing that you would like is to be able to stack images because that's another way to reduce noise. So the longer you take an astro image, the more detail you're going to see because the light builds up over time. And as more light builds up, you'll be able to see fader and fader details in the image. However, it's usually not a good idea to take, for instance, one image that's an hour long. There's a lot of chances that during that time, a plane or a meteor will fly through your field of view and ruin your image. Also, thermal noise builds up during the image as well. So it becomes a better idea to be able to take shorter exposures but then take those exposures and stack them one on top of each other to build up signal in your image. Doing that will give you almost the same result as taking a much longer image and reduce noise quite a bit. So we can see here two images. One is a single image, and you can see, although it looks nice, there is some noise in the image. But then if you take 32 of those images and stack them on top of each other, a lot of that noise is eliminated. So one imaging camera quality that you would like is the ability to take images and stack them. So in terms of video astronomy itself, I'd like to take a brief look at the history of video astronomy, where it came from. And so it's actually not a new idea. So this is an article written by Donald Menzel, who was the director of Lick Observatory in California in 1928. At that time, the idea for television had just been invented. I can't really say that television itself had been invented. Some of the initial ideas for television were coming out. But almost as soon as people invented television, people started thinking about how it could be used in astronomy. So we see here in the graphic that went with the article, the idea in 1928 was that several observatories would have telescopes that were connected to television cameras. And then those television cameras the telescopes would be pointed at the planet Mars, and the television cameras would relay a signal to a central receiving station where all those images would be combined, and an astronomer could lecture on what was on the surface of Mars with a very good image of Mars. Although it wasn't practical to do that in 1928, by 1961 it began to become practicable, although not easy. So here's an image of an amateur astronomer in Australia in 1961 with a video astronomy setup. You can see here behind him is his telescope. He actually has a television camera on a tripod. It's not actually attached to the telescope. It's just pointed at the telescope eyepiece. And he's dragged his TV set out onto the lawn and connected the television camera to it to allow him to view an image of the moon, and dragged out a chair and a stool so he could be a little bit comfortable as well. So at this point, video astronomy is doable, but it's certainly not easy. And the equipment is bulky, requires a lot of power, which a lot of places don't have if you're taking a telescope into a remote location. And the camera was really only sensitive enough to capture the sun, the moon, and some of the brighter planets some of the time. However, as time went on, things changed, and things really started to change in the 1990s. At that time, security cameras that were sensitive to low light levels were being invented and marketed, and some amateur astronomers got their hands on them and decided to attempt to use them for astronomy. The main drawback with security cameras for astronomy is that you can't take long exposures with them. They are limited to 32 or 30 frames a minute or second, so the astronomers took those cameras and modified them so they could do multi-second exposures, turn them onto the sky, and the results were very encouraging. You began to be able to see a lot of detail with cameras that could take exposures of even 10 seconds. Also at the same time, during the 1990s, people began to take webcams, which were becoming common back then, and see how they could be used for photographing and imaging the planets. Trying to photograph a planet is actually a very difficult and frustrating activity if you're using film, because film is very insensitive for capturing low light images like astronomical images. And so in order to be able to capture a planet like Mars, you need to take an exposure that lasts for several seconds. The problem with that is atmospheric distortion. So during those several seconds, the atmosphere will move around and blur the image of Mars. And unless you're very, very lucky, you end up with an image of Mars that looks something like this, with some detail, but not a whole lot. And this is probably close to about the best image of Mars that you would see before the invention of digital astronomy. But with webcams, you can actually take 30 frames a second images of Mars. They're sensitive enough that they can actually get a good view of the planet Mars. And the nice thing with those images is their computer software exists to actually process them, so the images that are blurred by the atmosphere can get thrown away, and the few images that are clear can actually be saved and stacked up. And so once people started using webcams to photograph the planets, began to go from images that looked like this to images that looked like this. And it was a quantum leap in amateur astronomers' ability to image the planets. And that is still the main way that planet imaging is done today. My introduction to video astronomy actually occurred a little less than 10 years ago. I tend to spend a lot of my summers in Massachusetts up on Cape Cod, and about a mile or two from where I stay is the Observatory of the Cape Cod Astronomical Society, the Werner Schmidt Observatory. And in that observatory, the Cape Cod Astronomical Society has a 16-inch telescope with a video camera on it. And so I got my first introduction to video astronomy by looking at the images from that telescope. My own club, the Amateur Astronomers Association of Princeton, has actually gone big into video astronomy. We have several large telescopes in our observatory in Washington Crossing Park down near Trenton, and several of them have video cameras on them, which we use for public outreach. And if you ever come here to UACNJ and we get a clear night, we have several EAA setups up here as well for showing the public the nighttime sky. So what is some of the characteristics of the video astronomy experience, as opposed to both looking through the telescope with your eye and doing long exposure astronomical imaging? Well, one of the advantages is you can see a lot of detail and color that's usually invisible in small and medium telescopes when you look through them. The eye tends to be very insensitive to color and detail in low light images. So in order to be able to see that, you need a huge telescope that brings in a lot of light. That's usually a telescope that's not easily manageable. EAA allows you to use much smaller telescopes and achieve the same result. So we like to think of it as a telescope multiplier. It'll take a small telescope and actually make it look like the image that you would see in a larger telescope. Since you're viewing in near real time, the image comes up within a few seconds or at most a few minutes. It feels more like the experience of looking through an eyepiece than astroimaging, which can take many hours to do. Relatively speaking, it's easy to use, as easy to use as using your telescope, very similar to it. It can't compete, though, with long exposure astroimaging for image quality. It wasn't designed to do that. So astroimagers that take hours-long exposures of an astronomical object and then spend hours afterwards processing are always going to end up with a much better image than video astronomers. But it's going to take them that much longer to get the image, whereas video astronomers can see the image pretty much immediately. That makes it great for outreach. So it's easy to see, easy to use, easy to explain, and more than one person can see it at the same time. So here are some initial video astronomy camera setups. The first one, and one that you can still get today, is an analog video astronomy setup. So this is very simple. If you have a telescope that you can use for observing, one that tracks the nighttime sky, you can get a small analog video camera for it. Usually runs about a couple $100 or so, and put that camera where the eyepiece would be on your telescope, plug it in, and then there's an AV cable outlet. If you have somewhere in your basement an old monitor or an old CRT TV that's sitting around, you bring that out, plug the video into it, turn it on, and voila, you have an astronomical image on your TV that you can watch. Then you can focus it the same way you would focus the telescope, move the telescope around to look at various images, and this is a very satisfying introduction way and low cost to get into EAA astronomy. A lot of people, though, will not have a spare monitor or an old TV sitting around. So another way to do this with basically the same camera is to get something called a video frame grabber, which you plug into the camera and then has a USB cable that you can plug into your computer. And instead of coming up on a TV, the image will come up on your computer. And a lot of times you can then take the image and process it if you want to. You don't have to, but you can if you want to. So this is the next step up in video astronomy. If you buy an EAA camera these days, most of them are no longer analog. They're completely digital. So all you really have to do is take the camera, put it in your telescope, plug it into your computer. The computer powers the camera, and the image comes up on your computer monitor. So this is what I decided to convert my observatory to. Would allow me to do imaging in my observatory. And after several years, I changed my telescope setup, took my 10-inch Meade and donated it to UACNJ, and got the following setup. So this is a 5-inch refracting telescope made by the company Astrophysics. It's a 130 millimeter Starfire Gran Turismo. It's the name of the telescope. It's on an Astrophysics Mach 1 Go-To mount, a very accurate tracking mount, also made by Astrophysics. And you can see the tangle of wires that are connecting to everything. Take a little bit of time and explain what all that tangle relates to. So this is the camera that I use. It's an Attic Infinity monochrome EAA camera. And it has some advantages and it has some disadvantages. The advantages are it's a very high resolution camera. Gives very good images. I'll show some of those in a minute. It has unlimited exposure time for those images. The software is very user-friendly and easy to use to capture those images. It allows images to be stacked and then after they've been stacked to be saved. It is a monochrome camera, which makes it suitable for narrowband imaging, and I'll explain in a little bit what that means. Some of the bad points, relatively for a monochrome camera, it's a little bit expensive, close to $1,000. It's not cooled, so that limits the length of your exposures. It has a relatively small field of view, and it is a monochrome camera. In the end of the day, who doesn't want to see a color image? But the monochrome images that it produces are very high resolution. Does have a relatively small field of view. So this is a picture of the Orion Nebula. The rectangle shows the field of view of my camera mounted on my telescope would give if I was trying to take a picture of the Orion Nebula. Another thing that I use in my observatory is a tool in order to achieve focus. It can sometimes be very difficult to achieve near perfect focus when you're doing astroimaging. So I use a very simple tool called a Bakhtinov mask, which is just a black cutout and has the slits cut in it that you see here. And when you put that, just take it and put it on the front of your telescope, it takes an image of a star and creates the pattern seen below. So you get, sorry about that, you get a star image that looks like a cross cut by a horizontal line of light here. And if you're too far into focus, that cross beam doesn't look like it bisects the cross. Too far, too close is the other way. But when you're in perfect focus, that light beam exactly bisects the cross, that's actually very easy to see in real time. You can set your camera so that it's taking 30 frames a second and adjust the focus just by adjusting the focus on your telescope and get near perfect focus very rapidly using a Bahtinov mast. So this is my dome computer. It's my HP laptop, which I keep in my observatory. It has replaced my star charts now. So all of the electronic components that are in my observatory that need computer control are connected to this laptop. So I can sit in my observatory and control my dome, my telescope, the camera, the focuser on my telescope, and the Bahtinov mask as well, which we'll see in a minute. So what can you see with video astronomy? So just to give you some examples, all of these images that I'm about to show were taken with the Attic camera on my AP130 in my observatory. They were generally images of between 20 and 30 seconds exposure time. And then I took those images and stacked up 10 to 15 of them for a total immigration time of about 5 minutes or so. In most cases, the images that you're going to see looked very similar to the way you'll see them after just 1 minute. And actually, the images that appeared on my computer screen were actually better than the saved images that you'll see here. So this is an image I took about 4 years ago of Comet 21P Giacobini-Zinner, which was a relatively dim comet. I think it was about 10th magnitude. Nothing really to write home about. But I wanted to see whether the camera would be able to pick it up, and it picked it up easily without any problem. You can see even a little bit of a comet tail here. Okay. This is the globular cluster, M3. So a lot of the objects that I imaged were objects that were discovered by the French comet hunter Charles Messier about 200 years ago with small telescopes visually. But this is a very nice, highly detailed image of the globular cluster M3, a group of about 500,000 stars. And here in New Jersey, where we have to suffer from a lot of light pollution, these globular clusters come through pretty easily in imaging. So it's relatively easy to get pretty good pictures of them. It's another globular cluster, Messier 5, the fifth object on Messier's list of non-comets that he was looking for. Probably the best globular cluster in the northern skies here for us is M13, the Great Hercules cluster. And just to see what my camera could do, because I was testing it out, there's a very dim 12th magnitude galaxy that is very close to M13 called NGC 6207. I wanted to see whether my camera would pick it up. It did so without a problem in a very short amount of time. This is the globular cluster M10, globular cluster M12, M53, M71, which is one of my favorite globular clusters, visible during the summer sky in the constellation of Sagitta. But in addition to globular clusters, I also can get pictures of galaxies. So this is the famous Whirlpool galaxy in the constellation Canis Venatici, the hunting dogs. You can see here the spiral structure in the galaxy, which was easily visible in the image after just 20 or 30 seconds of imaging. Virtually impossible to see from here in New Jersey unless you have a very, very large telescope. And even then, it wouldn't be as distinct as it is here in this image. This is the the galaxy M104, the Sombrero galaxy in Virgo. NGC 4565, the Needle galaxy. One of my better images of galaxies, M101 in Ursa Major, which is large enough that you can see a lot of spiral structure in the spiral arms. Okay. This is the very famous Ring Nebula in the constellation of Lyra, a dying star, similar to what's going to happen to our sun in about 4 billion years. called a planetary nebula. Another dying star is the Dumbbell Nebula in the constellation of Vulpecula, the fox. Yet another planetary nebula, and one that I was again using as a test to see whether my camera could pick it out, is the Soap Bubble, NGC 6781 in Aquila. This is NGC 6992, the Veil Nebula in the constellation of Cygnus. And the famous emission nebula, the Swan Nebula M17 in the constellation of Sagittarius. So one of the things that makes monochrome cameras an advantage is you can use them with filters. And one of the filters that's very good for astronomy is something that only passes the alpha line of hydrogen, called the hydrogen alpha light. The next image is also a picture of the Swan Nebula, but one that is taken with a hydrogen alpha filter on the telescope. And you get to see a lot more detail and a lot more nebulosity visible, again, in relatively short amount of time, 2 or 3 minutes exposure maximum. Here's a picture of the, the famous Eagle Nebula, also in Sagittarius, M16, also through hydrogen alpha. Showing the structure of the famous pillars of creation that were made famous by the Hubble telescope. This is a picture of the Crescent Nebula, NGC 6888, in the constellation Cygnus, without a hydrogen alpha filter, and the same nebula with a hydrogen alpha filter. So you can see the difference there. So this is me in my observatory. I did a few videos here. Unfortunately, the audio doesn't come through all that well, so I'll kind of do a voiceover for you. So this is my telescope setup, and I used it for several years and was very happy with it. But then I got the bug to do observatory automation. And as you can see here, you can see my dog walking around in my observatory, something that he doesn't get a chance to do very often. When I'm in my observatory, there's not a lot of room in there. And so if I spend several hours imaging, which is not unusual, I don't get a chance to move around that much, and it's kind of uncomfortable. So I began to think about plans to automate my observatory to the extent that I could control it remotely from a computer in my house and be able to do everything that I do in my observatory from my house as well. And that's the project that I've been working on for the last several years. Doing something like that requires a fair amount of thought, because when you're using a telescope, there's a lot of things that you do that you don't really keep track of until you have to try to figure out how you're going to automate them. So when you're automating a complete observatory, you have to be able to remotely control the camera, the telescope mount. For me, I have to remotely control the motion of the dome. I have to be able to focus remotely, and it'd be nice if I could control that Bakhtinov mass remotely as well. So the first thing that you want to be able to remotely control is the telescope, which tends to be, in a lot of ways, the most difficult thing to control, because telescopes have to be pointed very, very accurately in order to be able to see astronomical objects. They generally have small fields of view, and so if you point your telescope using your computer at some object in the sky and it's not in the field of view, if you're in your observatory, that's not really a big issue. You can get up, you can look at where the telescope is pointed, you can use a finder scope to try to locate the object, move your telescope slightly until it's centered, and then once it's in the camera field of view, you can adjust that until the image is centered and then go from there. If you're in a remote location, not in your observatory, that becomes very difficult to do. So what you want to do is have a telescope that is extremely accurate in its pointing. So what I've been using in my observatory is a piece of software called the Sky with an add-on called T-Point. that allows you to create a map of the inaccuracies in your telescope mount and then use them to accurately point the telescope using a software control. So you can control the telescope in the same way you would in your observatory. In my observatory, I have a small hand paddle that if I can push buttons, I can move the telescope north, south, east, or west. So here is the same hand paddle, but now on my computer as well. So I can just push buttons to move the telescope north, south, east, and west, or go to various deep sky objects if I so choose. So this is the focuser on my telescope, which is an electronic focuser. It's very nice in that I have the option to operate it several different ways. I can use it manually, so if I am in the observatory and just want to focus by turning the focus knob, I can do that. It's also connected to a hand paddle in my observatory, so I can use that to focus as well. And it's also connected to my telescope, so I can use remote software on my telescope to operate the focuser as well. So the way I mount my camera onto my telescope is with this off-axis guider called the Taurus 2 tracker. One of the advantages of me being in the hobby of astronomy so long is I've collected a lot of equipment which was originally used for one purpose, but now I'm repurposing it again. So this tracker was originally used when I was doing film photography back in the 1980s. And I pulled it out when I started to do video astronomy because it's a very good tool for video astronomy. There are several ports on the side of the tracker. One of them allows me to actually take an eyepiece and put it into the tracker and then lower it into the field of view. So I can actually use my telescope visually without changing my camera setup, which is very nice to be able to do. This is the box that houses the electronics and firmware that controls the dome motion. Shown above it is a little encoder wheel that allows you to track exactly where the dome has rotated to. You can see also some of the wheels that the dome is sitting on. The way the dome is turned is that there's two relatively large electronically powered sim motors that are attached to the wheels. And you can control that from software. And I can show you an example of what the dome looks like when it's being moved. So this is actually me in my observatory. I'm not physically pushing the observatory, but I'm using the hand paddle to control the motion of the dome. So you can actually, the dome is rotating, is able to rotate 360 degrees. And I can do that manually if the motors are disconnected. I can use the hand paddle if I'm in my observatory, or I can control the dome rotation from software on my computer. Here's a look at what that motion looks like and one of the motors that are doing it from inside my observatory. So you can rotate it in the clockwise direction, or you can stop and rotate it in the counterclockwise direction to any location in the nighttime sky, so that the dome is coincident with where the telescope is pointed in the nighttime sky. So how does the dome know where it's pointed? Well, there's a little magnetic switch that's attached to the dome and to the ring that it sits on. And I've positioned this switch so that when the telescope is in the home, or when the dome is in the home position, which is when the shutter is located over the door of the observatory, this is where that trigger is located, so it knows where the home position is. So one of the things you have to do when you're training your observatory to know where it's located is you set a software routine to go, turn the slot, the shutter so it's facing north, so it knows where the north direction is, and then it will rotate around, and as it rotates around 2 times, it will pick up where the home sensor is. So in software, it will know which direction is north and which direction is home, and that's all it needs to know to position the dome anywhere in azimuth to coincide with where the telescope is pointed. This is a look at the pier in my observatory now, and as you can see, there's been a lot of additions since my first telescope. One of the things when you do imaging is there tends to be a lot of electronics. So I have an additional telescope stand in here now that houses the power supplies for all of the equipment that I use, all still plugged into those 2 jacks on the pier. In addition, though, I've added this jack here, which is very nice. It's a quad 4 AC outlet that I have several pieces of equipment plugged into. And the nice thing about that is I can control them whether they're on or off through software. So I can actually turn them on and off from a remote location. This is the software on my computer that operates my dome. It's called Digital DomeWorks, also put out by Technical Innovations, who manufacture the dome. And you can see here, these are the 4 switches that control the camera, the telescope, my USB hub, and the focuser, and I can turn them on and off just by clicking on them or not. I can also sync the dome to the telescope, which is a very nice feature, so I don't have to individually control the dome. Whenever I move the telescope to a new position in the night sky, that information is automatically sent to the software that's running the dome, and then it does a calculation to know where the dome has to be turned to so that it coincides with where the telescope is pointed. One of the trickiest things that I had to do was try to figure out how to put that Bahtinov mask on my telescope if I'm not there. And then take it off again. So I got something called a flip mask from Alnitak Systems, and actually took a video of this. So this is all operated through software. So I can remotely close that flap so that the Bahtinov mask is on my telescope. Then I can take a few minutes to focus my telescope, and when I'm done, I can click the toggle again, and it removes the mask, so I'm ready to do my imaging. And one of the most difficult problems I had when I was organizing this setup was, as you could see when you saw the telescope in my observatory, there's not a lot of room in the observatory. And I had to position my telescope and mount and correctly balance them so that no part of the telescope would hit the inside of the dome as it was moving around. And at its closest point, the flip mask misses the closest point on the dome by 1/4 of an inch. And so I'm able to completely move my telescope around inside the dome without hitting the dome itself. So here's a schematic of everything that's in my observatory now. So my telescope, the telescope mount, which controls where the telescope is pointed, the hardware and firmware that controls the motion of the dome, the camera, the focuser, and the flip mask. And as you can see, all of those are connected to the dome computer by hardwired connections. So I can actually sit in my observatory and operate the entire telescope just by operating them on my computer. But the really nice thing is, now that I have that set up, I can use a Wi-Fi connection to connect my dome computer to another computer that's sitting in my den in my house, and use Microsoft Windows Remote Desktop to access the dome computer from my home computer. So once I've got everything set up, I can sit in my house and do remote observing in there as well. So as with everything in life, this is not an easy task to accomplish. Getting everything to work together, well, you've got equipment that's manufactured by a dozen different manufacturers and software that's manufactured by even more people, and you want to get them to all work together and play nice together, which doesn't always work all the time. I had problems with syncing the mount with the dome, which eventually I worked out. I had problems with Wi-Fi strength, so eventually I had to add Wi-Fi boosters in my house so I could boost the signal strength out of my observatory to the point where I could actually do this remote observing. And some problems with dome rotation that actually took quite a while to work through. So here's an example of one of the problems that I had to debug with my dome. So there was one location on my dome where when I rotate it in the counterclockwise direction, the dome motion would stop at one point. And this is that point right here. And the dome would not rotate any further. If you're in the observatory, this is not a big deal. You can give the dome a little push and it will go fine. You can even do what I'm doing here, which is rolling it backwards in the clockwise direction. Sometimes if you can power through this and it will work, other times not. And it became a real issue when I was trying to operate my observatory remotely. I eventually figured out that there were a couple of screws I had put through the dome to actually hold this wire down that you see here that connects the motors. And the ends of those screws were rubbing against the inside of the slip ring and creating enough friction that the dome stopped moving. And once I removed those screws, most of the problems were resolved. So I'm at the point now where I have a near remote observatory. So there are some things that I could have automated that I didn't. But my observatory is almost at the point where it could be what I call a remote observatory. So the skies in New Jersey are not the greatest. If you have a setup like my setup, there's a real possibility you could actually take that setup, because the internet is ubiquitous throughout the world, and move it to Arizona, where the skies are much better, and operate the telescope remotely in Arizona. But that requires a bit more than what I'm willing to put into my observatory right now. So if you have a remote location, you have to worry about things like the weather, whether it's raining, whether it's cloudy or not. There's been several times when I've been in my home, in my den, doing imaging, and all of a sudden the astro camera stops working, and the cameras won't find a new star, and the telescope can't move to a new location, and I'm trying to wonder what's going on. And I go out to check what's going on with my observatory, look up, and it's cloudy out. And once that happens, you can't do any observing. If you're in your home and your observatory is in your backyard, finding that out is not difficult. You just look out a window and you can see whether it's cloudy or not. If your observatory is 500 miles away, it's not easy. So if you have a remote observatory, you have to worry about setting up weather sensors that can actually detect whether it's raining, whether it's cloudy, what the humidity conditions are, so that you know what the environmental conditions are around your observatory. One of the nice things about the software that I use to run my dome is that it actually contains the ability to shut down the observatory if the weather deteriorates, and it does that automatically. So you don't have to worry about your telescope getting rained on. Another problem with remote observatories is security. So your telescope is sitting out in a field somewhere 500 miles away. Who's there near your telescope? Is it safe? Is the equipment okay? If you're not there in person, you don't know. And so that's always an issue with remote observatory. And then the final issue that's, again, a real showstopper for me is if you're not at your telescope and you're some distance away, what happens if something goes wrong? What do you do? And if you're in the observatory is in your backyard, that's easy. You go down and you fix whatever's wrong and then go back and resume your observing. If your telescope is on the other side of the continent, that's not possible. So one of the things that have become a thing these days is there are several locations out in the West where the weather's much better and people set up their telescopes that do what are called observatory hosting. So they actually have places where you can put up one of these remote observatories, but the site is monitored. There are people living at the location, and they will monitor the weather and send out weather reports. They keep the site secure so that your equipment is safe. And if something goes wrong, there's somebody on site that you can call, and they'll attempt to help you to fix what's going wrong. So that, for a modest price, that's probably the best way to do remote observing. So because I don't have a remote location, there are some things that I could have automated in my observatory that I didn't bother with. The first one is the shutter, opening and closing the shutter. So it's possible that I could put a motor on the shutter so that I could remotely control whether the observatory is open or closed. But being that the observatory is my backyard, if I want to observe, I just go and open the observatory myself. So I didn't feel the need to automate the shutter. The other is the weather controls. As I said, if I want to check out what the weather is doing, I can look out my window or go into my backyard. And if it's cloudy or it looks like it's going to rain, I can shut down my observatory by myself. The other thing that it would be really nice to have, and I've actually done this, is have a camera inside the dome so you can see what's going on when you attempt to move the telescope around, attempt to move the dome around, make sure that none of the wires catch on anything. I originally tried doing this with webcams, but they weren't sensitive enough. I eventually ended up getting a Ring security camera, which works spectacularly well. It's remotely controlled, it's wireless, it's very sensitive in low light conditions, and I can use it independent of the other cameras in my observatory to see what's going on in my observatory, and then shut it down if I don't need it. And I actually have one in my observatory now. I'm thinking seriously about getting another one. That'll give me 2 fields of view inside my observatory, and I think that should take care of most everything. And so to end here, I'd like to go a little bit through what my startup procedure is for doing my observing. It's now down to about 20 minutes or so. If I did not have my observatory and attempted to do all of this, it would take several hours to get the telescope set up to this point where I could do observing. Now it takes about 20 minutes. I open my observatory, turn the power on, turn the dome controller on, boot up the computer, start the software to operate the dome, power up the mount, the camera, the focuser, and the USB from that software. Start the software to control the camera, the flip mask, and the focuser. Then start up the sky, center the telescope on a bright star and focus it, and then sync the telescope with the mount using the sky. Then at that point, the camera is focused, it's on, it's ready to image, the telescope is pointed correctly. At that point, I home the dome and leave the observatory, go into my house, go up to my den, connect my home computer to the dome computer, which then mirrors what's on the dome computer, and I can completely operate everything inside for several hours and image in the comfort of my den. And when I'm ready to end the observing session, it's even simpler. I just desync the dome from the mount and home the dome so I can enter the observatory, park the mount, disconnect the home and the dome computer, and then walk out of my den, go down to my observatory, go inside, close the flip mask, power down the devices, shut down the dome computer, power down the dome, unplug everything, lock the observatory, 5 minutes, and I'm done. Which is very nice at the end of the night. You don't have to spend a lot of time breaking down equipment. And so some future projects that I'm looking at, and some of these I've actually done already. So I actually said about the in-dome cameras. I have one now, looking to get another one. I'm actually thinking about putting an auto guide telescope on top of my telescope so I can do long exposure astro imaging. I've actually done that and am in the process of implementing that. I'm thinking about, do I want to automate the shutter? Do I want to get an external weather station? that would give me a fully remotely capable observatory. I haven't decided yet whether I'm brave enough to actually operate my observatory from 100 miles away. Um, don't have enough confidence in all of the equipment working together. It's very nice to be in your backyard so that if something does go wrong, you can go and fix it yourself. And with that, that's the end of my talk. Hopefully you found it enjoyable and interesting. If anybody has any questions, I can try to answer them for you.
All right. Thank you, Bill. That was a wonderful presentation. So, like I said, we are actually live here in person on site. I do know I have some visitors outside who probably have questions. But before we get into our question and answer session, just a couple things to go over. Do check us out on our website, uacnj.org. That's where you can get information on all of the equipment here at UACNJ, as well as a list of all our talks ongoing. I'm hoping we're going to get a winter presentation list up soon. We're working on getting together that program for you guys. So, for our people who are actually outside in their cars or on the lawn, because I think I hear the rain has slowed down a bit, you're still going to ask questions through, I believe a couple of you have multiple phones with YouTube on them. I have been monitoring chat throughout the entire presentation. So if you do have questions, do get them in there. So normally what I would do is pass the mic between our online questions and the people we have. Unfortunately, I have a lot of wires I have to jump through, and that would be very dangerous to then jump through them and get outside, then get back in here. So I'm just going to do the question and answer session completely online. So with that, our first question is, are there problems with roll-off roof observatories that you run the risk of hitting the telescope with the roof, or I guess vice versa?
So the answer is yes. Usually when you design those, you design them so that the telescope has to be in some orientation that's low enough when you close the observatory that it won't hit it. If you don't have the telescope in that orientation and then try to close the roof, you've got a problem because the roof is going to hit the telescope. So it's always a good idea. The AAAP observatory, which is a roll-off roof observatory, has 2 telescopes, and we have to make sure that they're both level in their lowest positions before we close the roof so that the roof doesn't hit it. And the roof only misses them by about an inch when it is closing.
Yeah, I can say from personal experience with watching a couple of our members open and close the various observatories, we do have to actually put those telescopes in what we call a parked position because what's not a, I can't think of a better term than parking it because that is the safest place for them. The next question I saw was what type of roofs the observatories at UACNJ have? And actually, I believe you had said this during the presentation that we have all the roll-off style roofs, whereas you have the domes, the dome roof. So, yay, we get to deal with a little bit of everything. Let's see. Uh, sorry, I have to scroll through the chat on my phone. Uh, Someone had asked, you had mentioned you're in AAAP, AAAP.
Mm-hmm.
Does your club have any in-person events you're looking forward to, or?
So we actually run an observatory. We do similar to here at UACNJ. Here they're open on Saturday evenings. Our observatory is open Friday evenings to the public from April to November. We do have our observatory open again. We've removed most COVID restrictions. The only remaining restriction is there can only be a maximum of 12 people in the observatory. And we do have a lot of groups come out. If you're down in our area on a clear Friday evening, check out our website, and there's a phone number for the observatory there. Give us a call. If you get an answer from a human being and not a machine, we're out there, and you're free to come out and take a look through our telescopes.
Very much similar to what's here. Chances are, On that note, we always post whether we actually do have our live events coming up. Uh, we are coming up. This is the third to last, so next Saturday will be our second to last live in person presentation, and then we will switch to, for the winter, the completely remote presentations. Uh, just because as it gets into the colder months and we start having to combat the consistent ice and snow, it just becomes a little bit more hazardous, especially with parking. So we do switch to remote, and we'll resume our live in person presentations the first Saturday in April. So let's see. The next question is, for an observatory or viewing at home, how would you combat directly overhead light pollution or noise? Uh, Basically, light that cannot be blocked by trees or whatnot.
I have this situation that I have to deal with. It's very annoying and very difficult. Where I stay in Massachusetts, the backyard there it's a little bit more blocked than my backyard here in New Jersey, but still you can do some astronomy from it. But I have one really irritating, very bright street light that is virtually directly over my backyard, and that is very difficult to block. Uh, there are a couple of things you can try to do. Um, if you can find a location that is where that light is blocked by trees or posts or something, you can observe from that location. Barring that, I've seen some people even take a dark bag, on a long pole and put it up and cover the street light while they're observing, and then be careful to remove it afterwards so you don't get in trouble with the police. But that does work.
Yeah, I will say we are not condoning any vandalism of public infrastructure. Uh, we definitely would never suggest that. Uh, I would imagine just even putting up a couple of flagpoles set up as volleyball net ish with just a little blocker would possibly help. Again, sometimes creative solutions are available to you. It might be something as simple as uh, being able to talk to your local town. Hey, can we orient that light just a little bit differently depending on where you live? You never know until you ask. And again, please do not mess with public infrastructure without permission, because that would be extremely dangerous and probably carry a significant fine and or jail time. Just like getting run over with a car when they're not using headlights. Would not suggest 0 out of 10. So the next question we got is, someone had noticed you possibly have a small music player in your observatory.
Yes.
Does the music actually interfere with the telescope or observing?
No. When I'm in my observatory, I do like to have music playing. Um, uh, I've, in the past, I was actually working on a professional astronomy project with an astronomer at Princeton University at their observatory. And we would always do, the amateurs who were helping him to run his project would do late night sessions, 4 to 6 hours, going from like uh, 10 o'clock to 2 o'clock in the morning. And we would always be playing music, and people would ask me what music I would be playing. And they're thinking, the music of the Spheres or something, very soft and instrumental. And I would say, no, I didn't do that. If I'd played that, I would have been asleep in 5 minutes. What I did was I played acid rock as loud as I could get it, and for the 4 hours to help me stay awake.
Well, yeah, when you're sitting in a place for a while, you definitely don't want to be bored, and lullaby your parents saying to you when you're a kid is definitely not a good idea. When the lights get dark, yeah, it's nap time. So I could definitely understand wanting to stay awake with that one. All right. On that note, I actually have a question that's a couple ahead, so I'm going to skip this next question, but we will come back to it. What is the longest time you have imaged or observed for?
Uh, in like a single session, probably about 4 to 6 hours. When I was doing film imaging, back in the 1980s, that required a real dedicated effort. So in that case, you couldn't break up the image into smaller chunks. You had to do it in one sitting and hope that it worked at the end. So it would be not unusual that I would be sitting doing imaging in the freezing cold in the winter for 3 to 4 hour stretches at a time just to get a single image.
I'm really glad I'm not into astrophotography because I like the cold. I don't think I like it that much. All right, so back to that question, like I said, that I had skipped over because I thought that one was slightly relevant to the topic at hand. Uh, do you have an opinion on what the best telescope setup is?
So that's a really loaded question. Telescopes have very many uses, and the best telescope is one that you use a lot. So I've had a big number of telescopes. I've been doing this for 50 years now. And the best telescope that I ever had was one of the cheapest. It was an 8-inch Coulter Dobsonian telescope. Cost me about $200. Very cheap, but the optics were reasonably good. And it sat in my garage, and I could look outside and say, oh, it's clearing out. I'd like to go do some observing. I could take it out of my garage and be completely set up in 5 minutes. And then 20 minutes later, it gets cloudy. I said, oh, time to go back in, take it, put it back in my garage. 2 minutes later, it was done. And I use that telescope all the time because it was so simple to use. And I saw more than 500 deep sky objects with that telescope just because I used it all the time. So the best telescope is the one that you use the most.
And I fully agree because a lot of people are out here spending that money to get the greatest and best equipment. But if it's a pain to set up, you don't know how to set it up, perhaps it wasn't the best choice because if it's a pain to set up, are you going to use it? At which point you are better off. Like many of our observers have and volunteers have suggested here, start small, work your way up, learn how to use the equipment you have. Just because you will be able to get an idea of what direction you want to go in, what you actually want to spend your money on. Uh, Join your local astronomy club because they will help you. Chances are they have scopes you can borrow that you can use to look through. If you currently have a scope and you're having a little trouble, they're also the resource you're going to want to see to actually go see, hey, I'm not quite sure on what eyepiece I should be using to find an object. They're going to be able to answer those questions for you that otherwise would have your scope collecting dust in your attic or garage or wherever you have it. So, let's see. The next question I see is, what operating system are you using to control your system? Or are you using a lot of open source software?
Not a lot of open source. Most of the software that I use was made by the manufacturers of the equipment. So Technical Innovations, which made the dome, also created the dome software that I use. The telescope is controlled by the Sky software from Software Bisque. The focuser has its own dedicated software. The flip mask, the same. The challenge is kind of getting them all to work together nicely, which I've finally managed to do after multiple attempts.
Yeah, you have taken the approach to, I have I've been given all these tools. Let's make them be friends and work. I know there are a couple observers who have said, I'm going to do it myself and have actually made programs. I believe Mark Sproul has been one of those who have actually made their own. So some people find it better to use what you have on hand. Very resourceful option. Other people who are more advanced and technical than I will ever want to be and could ever dream to be in my lifetime are choosing to make their own. So there's always an option. And again, you can find a lot of about just looking at the forums, going to your local club, because chances are you have a whole array of all types of people who can do that. So let's see. The next question I actually think is someone who's probably thinking of a caterpillar backhoe situation. Do you have issues with things unscrewing themselves, aka rotating too much in one direction?
Not a whole lot. Um, the dome doesn't have that problem. I usually tighten stuff down so that when the scope is moving, nothing can rotate freely. And I control the motions of everything else myself and track them so that I can see what they're doing.
Yeah. And I believe actually instead of unscrewing the self themselves, the problem we actually more commonly have with telescopes that are on mounts with wires attached to them is what we call wire wrap, where it does, you can't go too many times in one direction and then the wire basically has constricted itself around like a unwieldy, very thin spaghetti snake.
And one
Um,
of the nice things about the mount, and one of the reasons I chose it, is it has the capability that all of the wires that come down from the telescope can be run through the mount, which eliminates the wire wrap problem.
yep. And if not, that's another piece of, I believe, software, not firmware. There's some electronical bit with programming involved that actually can prevent that. I do know we are running that on, I believe, the astrophysics that we have here. So, next, were there any more questions online? Sorry, I noticed I had skipped around a bit, so I'm just scrolling back through to make sure I didn't miss anyone. Now would be a good time, like I said, to get any of those last minute questions in. And actually, not seeing any new ones, but let's give you guys another minute or so. In the meantime, I actually have a question I've asked a couple presenters before me because I found it interesting on one. If you got a chance to go to Mars or the moon, would you take it?
Uh, in my younger days, yes. I think I'm getting to the point in my life where I would say maybe. Although, was it 2 days ago? William Shatner, who's 90, became the oldest person to go into space. If Jeff Bezos offered me a ride on his Blue Origin rocket, I think I might take that.
You'd go Blue Origin, not
Mhm.
SpaceX?
SpaceX is nice, but Blue Origin goes higher.
All right. So like I said, it looks like we're actually out of questions for the night. Uh, so just going over a couple things. For our people out there, if you need to use the restroom, it's the porta potty with the red light on it that I'm pointing to. That of course you can't see again. It's habit at this point. Uh, the doorway on the house, surrounded by the red rope light, is actually the doorway into a little gift shop area. If you're scouts or whatnot, you can find patches, T-shirts, and a couple other neat things that we have in there. Again, check us out on our website, uacnj.org. We have Facebook, Instagram, Twitter, Discord server going on. All of links you can find through our website. You can also check us out. We are a nonprofit, so all of your donations have been super helpful. I want to thank you all for what you've done. We've been slowly growing and bettering our wall of stars. A couple people from online have actually gotten up here. They've donated through our PayPal. We also have a Patreon that we're attempting up, where if you want to do like a little monthly subscription type thing, you can get on board with that. Um, Besides that, I want to thank everyone for watching. I thank everyone for coming in. I want to thank you, Bill, for another wonderful presentation. And until next time, have a good night.